Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. It was written with one style parser, and we're trying to evolve it to a new style parser. So it started off recursive descent, and we're going to a parser combinator approach. We've done a few of the grammar rules, and we have a number to go. We left off looking at the statement. So we did single line statements, which is one or more statements, and we just started to do this big statement one, which is data or def or dim, etc. And just a straightforward A or B or C messed up. So we've got some work to do there. All right, let's see. So basic parser. So here's we're trying to make the single line parser, and you can see match data or def or dim, and thinking about things. I think what we're fighting, like you can see that we had some red tests. I think what's going on is the method assumes the first character or first symbol, first token is already there, and the match data is consuming it. I think, let's see, let's take, yeah, you can see it here. So match consumes the token, and then the original code said, okay, now eat the token. Well, we ate it there, and now we're working on whatever's after the token. So that's causing a problem. I don't know if we can. I don't know if this is necessary. Did we try it? Okay, let's take this off and just say match data, and let's look at these tests. Okay, so here's a simple data statement. Let's see what happens here. The other alternative we have is I think we can kind of peek and then decide what to do. Okay, so still failing. At least one variable is required. At least one variable is required. Okay, so somehow that is not hitting the data statement, I think. Let me look at data. Okay, so it needs to eat the next token. Oh, interesting, but it never really looks at it. I mean, that's done in the statement. Okay, let's go back, undo that. Let's do the peek here. Peek match data. Okay, so now peek is a combinator that it attempts to run this parser, and if it succeeds, it just returns a hard-coded 0, and if it fails, it fails. But it doesn't consume input when it succeeds, so it just says I did match data, and then go on and call the data method, which is going to eat the next token and so on. So let's try this, and I think I want to go back to the single bar. All right, so data read tests. Still not that. Expected a data value. Okay, this is confusing to me. Let's try this. At least one variable is required. Okay, where is that message coming from? Or okay, let's do something easier. Let's do end. I'm gonna move it up. And I'm going to look for that at least one variable. What method are we in? Comma list of variables. Who calls this? There are several places. Okay. A read statement. Yep. And yeah, okay. Read. Input. Okay, so we're not getting the right parser. Okay, well, let's go back. All right, so I'm going to try and match the end statement. I think. Okay, let's find the test and then make it fail and then worry about it. Okay, and here we go. This one passed. Okay, that's an interpreter test. Let's find a parser test. Oh, I guess this does. It wasn't interesting enough for the parser tests. Okay. Here's one. Dead end. Okay, I think that's actually progress. Extra characters at end of line. Yeah, so I think we're consuming too much. And so if I've matched end, I don't think I should do the next token. I think I should do this. Okay. Let's run this test again. Test 10 end. Okay. What does that tell me? Okay, I guess my claim is this around it with the next token should be okay. So it should say, try to match an end. If you do, go ahead and do the statement.end code, which will consume the next token, which we know is an end, and then return that. Okay. I'm hoping these are equivalent. Okay. Now let's move on to a data test. So my claim would be then that this data statement should work the same way. It peeks, finds the word data, goes into the data method. First thing it does is throw the token away. Okay. I don't know that it's necessarily better, and I think we won't need to do this in the long run, but for now, that works. Okay, let's make sure we can do a data statement. Parser tests. Find data. Data with single number. Okay, that seems like a pretty minimal example. Okay, let's do a couple more. Where's def? I don't think I need those. Def define helper function. Okay. This should fail now. If I put the peak in front of it, it should pass. And all the def ones should pass. Unknown statement. Oh, this is a problem. Okay. def. I think this thing is getting in my way. Let's try that again. No. Unknown statement. So it gets into the def statement and it sees this. My worry is the syntax error handling is interacting with this backing up, and it's just kind of like, well, if you don't match, we'll just try something else. And eventually we get down to the bottom and go, well, nothing matched. So it must be an unknown statement. And I think, I don't know, I put all these in yesterday, but I think maybe they're hurting me. And I don't have an easy way to switch between them, unfortunately. Okay. Let me just run them all. I don't think this is enough to do it because these other things are... Yeah. Okay. Let's make a helper function. Function when takes a token, returns a peak. Peak match of token. Implicit return. Okay. Generic peak requires what's the type of this thing? Satisfy? Okay. I don't know, maybe I'm burying myself. Cannot convert token to token type. This is a type. Okay, does that work for the end statement? Just an end. Okay, let's see. I may... I don't like being 15 minutes in without a solution on this. I think... Yeah, I just don't know. Otherwise, okay, this one just defaults. Okay, let's see if we got off easy, and if not, we'll figure it out. Okay. So, what do we got? We now have make single line parser as a statement parser that has all the old parsers in it. Okay, now I can this parser error, I could modify this to a new style, I think. There's another form that says if you've got a bunch of alternatives and you don't none of them apply, then you can just put a percent in a string, and that should be the same. Okay, so let's keep it like that. What we've done is make the big alternation of all statement types be in the new parser. Okay, so recursive descent, I'm going to bounce down to one of these. In recursive descent, we're writing these routines like this. You assume the token is correct, and you match. You can use ifs and whiles and so on. So this one, I guess input lets you put a prompt, a string, and then an optional followed by a semicolon. Otherwise, prompt or not, you have a comma list of variables. So you can say input XY, or you can say input what are X and Y, semicolon XY. And there's a routine for each grammar rule. The new way we're writing basically the operators of the grammar rule are combinators. They're functions, returning functions that do parsing. All right, now the tricky thing we have in here, here's statement. Let's see who calls it. Okay. Statements. All right. And then this one is under, it's also statements. Okay. So the old one, so who calls this? Yeah, there's one place, and this is the if statement, I think. Yeah, if then. So if something then, and you can have a bunch of statements. And now we've got this conflict. There's a mutual recursion here. Statements eventually gets down to if then, which calls statements. And we've got a restriction. It's actually an artificial restriction, but I'm making the restriction that says old parsers can't call new ones, but new can call old. And so we're leaving the structure for statements in place, even though the top level we're parsing with our new style. So let's go back up to make. Okay, yeah. So here's the make. Make single line parser builds on statement parser, and then statements parser allows one or more statements separated by colons, and this, let's see. And then, yeah, lines contain statements, and then we actually parse the line. Okay. So we have two ways to do statements right now. We're going to leave that in place until we modify if-then to be a new style parser. Okay. I don't think I have any changes. No. Okay. So what I want to do is, well, I want to make, I'm really feeling the if-then, that pain of not being able to delete those intermediate layers. And I'd love to get rid of the statements and statement parsers but I can't until I do ifThen. But I also want to kind of demonstrate that I don't have to do it. I don't have to replace that right away. We're shippable right now. You can, everything runs. And I guess my way of demonstrating that is going to be like, how about if we just replace a few of these parsers first. We'll do a couple and then jump down and do if, so we can clean things up a little more in a more straightforward way. But we could, it could be that in some languages there might be lots of things that contain multiple statements, if, while, then, repeat, and so on. We can't just say, oh, we can only do the first one and it's all fine, so but in our case we'll get there. All right, so I'm going to look at each one of these parsers now, and this is a mix of new and old style. But what I'd like to do is I'd like to say this is really match.end, and then you're just going to return, well, you get the end passed to you, so this, but we're going to return statement.end. Okay, and I think this is the new style parser for an end statement. That should be a drop-in replacement for what we have there. I don't need the wrap old anymore. So, okay, so if you match the end statement, it's a one-word command, and we pipe it to a function that converts the token to the actual statement. Okay. And yeah, just run them again, make sure. I guess I could probably make it look like basic. Okay, and so here we've done statement now. Well, end is a one-word statement, so we're kind of working on that. Let's take this. All right. And let's just do data. Okay. So data, let's see. Let's go to this method. And I'm going to define the parser based on what I see. Okay, this is a little funny. Okay, so it's really... I'm not really sure what the right way to put that in is. All right, so this, well, let's start. Data parser equals... well, we need to match a string. Well, it's really the word data. Match data. We can ignore the match. I mean, we don't need to do anything with that word data semantically. Match data, and it's followed by string, match string, I'm not clear how to enforce that error. Well, what it really looks like is match string, and then separated by comma. And actually, we don't need the commas either. Okay, so this expression gives us an array of strings. I don't know. This may be a case where we won't handle the error messages right away. Okay. If it worked, okay, data, it's it's going to create an array of strings. It's going to match a string, append it, and then look for comma separated strings that comma separated strings that get appended, and then we form a data statement with the strings. So I guess this, well, this goes to strings in data of strings. Okay, because this construct builds up an array of strings. No, it's got to be the strings. It's an array of tokens. Probably should have picked an easier one, huh? Okay. It's an array of tokens. We need to map them to strings. Okay, so map an array of strings. Well, I guess that's, I think we can just say map. Map $0.string gives us an array of strings from the tokens. Cannot find map. Okay. Let me minimize this. Let's not worry about that. Swift map array. Array.map. Okay. How's that working? Build failed. Invalid conversion function cannot invert type for closure of multiple statements. Array of token throws to non-throwing function type. Oh, well, I don't have a brace. I just can't help. Okay, that's better. Okay, so here we've mapped our array of tokens to an array of strings, and then let's map that or turn that into strings in data of strings. Okay, so we're basically separating out the semantics from the parsing. So if you match all this stuff, okay, so match data, match a string separated by commas, turn the tokens into an array of strings, and map turn the strings into a statement. Okay, I think that is the same except for error handling, and I don't know. I mean, I went through this before with the last evolution, so you'd think memory would kick in at some point. But it looks to me like it requires the first string. Oh, maybe I can put it here. Expected data value. If you don't get it, then you complain. That seems appropriate. Okay, let's pull this up. We've left this how it was. Go back to our make. All right, and let data parser equals that. Okay, so now I'm going to substitute data parser for this. I don't know. I like the formatting like this, but the IDE disagrees. Okay, so we're saying, or you can match a data statement, do all this stuff rather than calling the wrap old. Let me just comment this one out and call data parser. Data parser. Okay, so this data strings separated by commas, convert the strings to the tokens to strings and use the strings. Okay, and this should all pass. Sometimes these things work better than others. Yep. Okay. So this is a data statement. Whoops. Okay, so one word statement. We got some of those done. I don't know. Can I go on? Let's take another easy one. Maybe we can get this out. A read. Okay, so we'll match read followed by a comma list of variables. All right, let's try and define this. Read parser equals match read followed by what counts is a wrap old self comma list of variables. Comma list of variables type is array of expressions. So I think we just take this. We have an array of expressions. Let's just return a read statement for it. The type, it may not, yeah, it doesn't know this is a statement. Okay, let's try read parser. Now tests. All right. So that okay, that was a read. Guess I'm not good at marking in progress, am I? Well, this time I'm going to do a single one, which is the remark statement. So it's already marked in progress. This one, maybe I can just do inline. It's pretty simple. So, or match dot remark, and it just skips the token and returns skip. All right. I'm not very consistent, am I? All right, rem. This one's kind of the same. Okay, but instead of remark, it's stop and return statement dot stop. Okay, and then I just want to see this thing. Well, that looks a lot like it too. Okay. Return. Match return. Pipe 2. And this one. Match restore. Okay, we've done all those. Put this over here. Whoops. Grab that. Okay, so those all ran. Whoops. Handle one word parsers. We had stop, restore, return. Okay, so I mean, I think I've demonstrated that we could tackle any of these. You know, some of those were easy, but some of them were a little more challenging. It's pretty clear we can use those parsers. We can migrate parsers one at a time. Now, what I want to do now is tackle this if statement, and then we can clean up the old statement stuff. We actually have to do a little more work, but we'll get there. Okay. Maybe we should do the work first. So the work is statements parser. So right now we know the single line parser, we make it, and it eventually calls the statements parser. But if we go find our if then, if we find our if then, okay, it calls statements. And so we've left the routine around, but we need to be able to call that parser. So I think what I want to do is pull out a make statements parser and have a function for it as well. Okay, and then also have a field for it. Okay, so statements parser is going to give us, well, what does it give us? It binds from token to, we got to find that type. And these are horrid to read. I will warn you if you haven't been here for it. Yeah. Somewhere I want it to say, well, oh, I know what to do. Let's go find the other statements. I think it's going to return us an array of, yeah, statements. Okay, so this is our result type. Array of statements. Bang. Okay. And then it has to be defined. And make single line uses statements, so we need to define statements first. Make statements parser. Okay. And I'm going to extract that from here. Okay. I'm going to extract it here. File, parent. Okay. That gets to this. Now we have the statement parser. Statements parser. Okay, so let's do a bind token to statements of statements parser dot parse. Just the function. Okay. So you can tell me, cannot assign bind token expression to bind token statement. They are not equal. Statement parser. Well, this should produce an array of statements. I guess if I saw array of statement in here somewhere, I'd be kind of happy. And it's not. Statement. Statement. Sorry, statement parser should produce statement. And I think, I mean, it would complain if these types weren't compatible. So I think this produces statement. This should produce array of statement. Okay, let's see this one. Bind token parse. Token array of statement. Statements parser. Ambiguous. Oh, golly. Cannot assign value type bind token expression array to bind token statement. Did I say expression somewhere? What's going on up here? Statements parser. Cannot assign value of bind token expression. Oh, I did. Golly. Okay. Okay, this should run with no impact because I'm not calling the new, I'm calling it, but I'm not doing anything with the result. Okay, now I want to make this thing depend on statements parser here. Okay, so I will comment it out. he calls the field now. Again, this should just work. Okay, let's undo these comments. Okay, so now we have a function that builds the parser for us with statements, and then another that builds the single lines out of that. And in here we have parsers for individual things. We could imagine we might have some that are complicated enough that we don't want to do that, but that's okay. All right. So I think what we want to do next is let's tackle this if statement. So let's find if then. Okay, so we'll tackle this. We've got some semantics beyond where we've been so far. Okay, we'll see. This is a little more complicated than some of the others. But I think let's take a break. It's a good time to take a break because this is going to be a long step, I think, to get all the way through it. So let's take a 3-minute break and we'll come back, handle this if statement, clean up the other ifs and the recursive stuff. And then I think at that point we just are knocking off one at a time until we get through the whole list. And so I'll say we're active here and we'll take that break. Welcome back. All right, so the if statement. Okay, so let's start defining that parser, and we're going to run into a couple things, and we'll see how we want to deal with it. I guess I could say if then parser. All right, so we have to match the if. The if we don't need the value as usual. Okay, then we're matching an expression. So that's a wrap old self expression, the method name. All right. Then we need to make sure that the expression is a float type. So let me hold off on that one. Okay. Then we need a then. Let's see. So that's, we care about the thing on the left. We don't care about the then so much. We match then. Okay. And I think we can say this is, just to kind of be clear, that is kind of a piece together. This expression of the then. This, okay, required float type. We're going to ignore that. Then, okay, then there's two possibilities. It's either, well, it's followed by either, again, I'm trying to make it read properly. Okay. It could be followed by an integer. Match integer. And if it is, we're going to take that token, turn it into a line number, and make an if GOTO. Okay, which I think we can do here. So given the integer, let's turn it into a statement. It gives us a token, and we're going to say statement.if GOTO with, oh dear. Okay, the expression has to come from here. We got to arrange our operators to give us this piece. Well, I think maybe we'll put that here. Trying to figure out the best way to do this. Okay, so we match the if, and then we want to do wrap the old. We got to have that. And then I think this is where the choice comes in. So we're going to be followed by, nope. I got to have the expression in my statement. Okay, so this branch, match the if, wrap old, match the match the then, and match the integer. Okay, so all of that, match the expression, match the then, we just keep the expression and match the integer. That means we're getting a pair in here. Okay, so this whole thing then can pipe to expression token in, and this. Where this is expression, and this is line number token dot float that we did before. Yep. Okay. That is that. And then this whole thing is an alternative, or some other thing followed by that. Okay. Whew. Okay. So I don't know. This is okay. If it's not an integer, then I think we're looking for the same thing as far as this. Okay, let's separate things out. Let then go to equal this. Okay, so we got expression then. How about expr then go to is that one. And this comes out and it's just expr then go to. Or you're going to match expr then statements is, okay, where's your parend? match an expression, match a then, match an integer, and convert it to an if GOTO statement. Okay, this one, it's going to start the same. And then wrap old self statements. That's the recursion. And if you do that, then we do the if statements. Wrap old statements and then pipe this to expression state. Well, let me abbreviate just to make sure I'm not overlapping IDs. Expr statements in this, and I probably have to tell it this is a statement. If expr statements. I don't want to reuse that function name. Okay, and I'll format this the same. All right. So this is where there's some backtracking. So I think you actually do need this operator. Okay, so I think this is pipes to that. I think we can even put it on one line. Expr then GOTO or expr then statements. All that goes away. Okay. Initialization not used. Okay, that's progress. The thing we don't do. Oh, let's make this the same. All right, yeah, so I'm saying you must match an if, then you want whatever results from this. It's either expr then GOTO or expr then statements. If you get this operator with two bars says backtrack. If you get the then and the integer, then you want to do this one, and then you'll just do the function. If you don't, then go back, and then you'll get an expression of then and hopefully some statements. Whichever one gets farther will catch the error message of the whole thing. All right. But this is still missing something. It's missing this. I think what I want to do is pull this up. Okay, I defined it here because that's where I can kind of make sense of it, but it really belongs up here. Statements. Okay, here's data read. I guess I'll put these alphabetically. Expr then GOTO, expr then statements, and if parser. And let's use if then parser. So what I'm expecting is that I'm expecting to get error messages about the required float type. If then parser, is that what I called it? Yeah. Okay. And I don't need this one. We'll just comment it for a moment. Okay, so I expect most if things to work, but the ones with errors definitely will have some issues. And I often do it this way, that I like get the syntax right and then I worry about the semantics. Okay, one failure. I better be a semantic error type. Yes. Okay. No error found because we didn't enforce it, but you're not allowed to say if $1, it's got to be a float type. Okay. We have a mechanism for that. We haven't used it yet, so that's why I held off, but now's the time. All right. So I think I'll live with this tension of one failure while we fix it. And let's go back to the if-then. If-then require float type. Let's see what's involved in that. It's not too bad. All right. Unfortunately, it's going to get worse. The mechanism we have, let's see, it's not bind, it's check. Okay. So you call check, and it returns either success or failure. So it's returning a parse result. So it's not quite a parser because its input is different. It's not an array of token or array slice of tokens. It's a bunch of values and the rest of the input. So it's kind of an intermediate parser kind of thing. But we're going to write the function like this. This is the thing that checks the constraint. So if the constraint is met, we return a success. If it fails, we return a failure. I'm going to copy this even though it's not really particularly on point. Okay. We can get the structure of this. So this is require float type. We'll just keep the name the same for now. All right. And then the value it gets, well, it just gets an expression. And the array slice is token. We know that. And it produces an expression. Whoops. That should be token, and string should be expression. Okay, so input type is expression. The parse, the type we're working over, the input stream is tokens. The result is a parse result over tokens that produces an expression. Okay, this stuff is all just kind of junk. We're really after this. These kind of lines. Okay, so they're probably more informative. Okay, so what we're going to do, we got to make a decision. Is the type right? Okay, so I would say if the expression type is number, then let's do the success. Return success. Well, it was showing me before. Return success. Okay, expression and array slice. Okay, so that's expr, and the array slice is the remaining. Okay, otherwise we're going to return failure, and we need the token. Well, it's the position of the token. I think we'll use index of token. I think this is what we'll do consistently. And then the message is numeric type is required. Okay. All right. So it's a very similar test. We're just saying returning different. We're not throwing. We're returning an actual sum type, success or failure, or enum type. Expression is number. Return success with the expression and the rest of the input. If it's not a number, return the position of the token and a message. Okay, so that type we can use. Let's go back up here. Got to find our if statement. So this REPL, and unfortunately, I don't know how to get rid of this duplication. Okay, but we need to do it in both cases. Okay. I don't know, would it help to plot a float expression? Well, let's see it work, and then we'll decide how to refactor it. Oh, okay. Then we get an unknown statement. Oh, okay. Um. Again, this is this backtracking thing that's going on. So it's going in here. It tries to do the expression. It checks it. And it fails. So it backs up and tries EXPER-THEN statements. I'm trying to think if there's a way to, I don't know. It's almost like I want to push this into here. And maybe that would be the way to go. Okay. Oh. This is an awkward place in the grammar. Okay. I don't know. Can I? No, the problem was. Yeah, I don't know. Like, I want to embed this in here instead. Can I do that here? Or can I make a failure here? What if it failed there and I said, well, what's my expectation? Numeric type is required. What if I use that error clause thing? So try the statements. If you don't have either one, then you should have had a numeric type. Let's see if that does it. Okay, I guess I can live with that. So what happened before was it was backtracking. It got through both of these and it said, wow, this is an error. I think this whole thing is not an if statement. Let's go on and try some other statements. And none of them qualify, of course. And so it gets down to the bottom and says unknown statement. Now, by putting this up here, I said, if these two are equally bad, then give this message. So that I think that will capture it. Now I'm wondering if this is really, if it's not a float type, it seems like it's coming in through here. If it was a float and it got missing then it would trigger that. So let's make sure we have a test that looks for missing then. Yeah. Missing then. Okay. Well, there is at least one test for that. If zero print. Okay, so we're getting this message appropriately. That's fine. Then unknown statement. Okay. I think we're okay. All right. So we've got handle if then with new parser. Okay. Let's see. So let's find if then. Okay, that's called here. This is the only one that tries to call a new style parser with statements. Okay, so I want to say, let's see where we're using that. We do a wrap old, I know. I think we just wrap old expression. Wrap old statements. Okay, we're still calling that. I would like to get rid of that. And this is a little tricky and unintuitive too, I might add. Okay. We're going to create the parser so you can reference it. Notice it's not available for reference yet. Okay, so let's do that. I guess I need the, this is going to be a long method too. Okay, so let result equal bind this with nothing defined yet. Okay, so we're, let's see, I want to be statements parser. I got to do this right. Okay, initialization of result. Okay, and at the end we're going to return, we're going to bind it and return it. So result dot bind to statements parser. Dot parse. Okay, and then we return result. Okay, I believe this will work the way we are now. I don't know if I'm quite where I need to be, but let's make sure this works. Okay. Make statements parser uses bind method. Okay. Now the thing is, I think I really need to make this be statements parser. That's where this is going to get a little tricky. Okay, so yeah, I can't redefine it. It's well, let me just rename it for a moment. This is statements parser, and this is statements parser. Okay, and then this, it can't bind itself. It's got to bind. It's got to bind this. The statements parser.parse. Okay, this should still work. So what I'm doing with bind is when you create this bindable structure, I'm saying create a statement parser. Its type is bind, whatever, and I'm not going to tell you what parse method it uses, but now I've got a statements parser that I can reference in my local variables, and that way I can reference it in my if, but at the end I have to kind of close the loop and say, okay, the whole thing really is this parse method. Okay, and then we'll return that statements parser. So that worked. So now we've bind statements as a statements parser as a local bind parser. Okay. And notice our overall parser is also called statements parser. So I know I'm messing something up. Am I? No, I think not. This becomes set to the global one, which is the one we've been working with up here. Okay. So this crossover point now, it's here. Wrap old statements, I'm going to call statements parser instead. Okay, so I'm calling the end result of this whole big statement, and it's recursive, so I can't just define it because it doesn't know what parser it uses. So I define it with a bind, so it defers that. Okay, now the test is, does that work? Of course, but it's supposed to. All right. It feels tricky, but it doesn't take long. Okay, so make the if-then parser use the new statements parser. Okay, and so that's really like this tipping point for handling statements. Now, who's calling statements? Look for statements. Okay, there's the function definition. It's referenced in if-then, and it's referenced here. So let's find who's using calling if-then. I guess that's still an open thing. If-then, okay, is in statement, which is called by statements. Okay, so my claim, I guess, well, the claim is the if-then is no longer needed. Okay, that our if-thens are being parsed by the new style parser. Okay, and so there's gonna be some consequences from that. Somebody's gonna complain. Yeah, because we're calling if-then. Okay, I'm just gonna delete this case. Okay, and should build, should run. Okay, that's kind of a good point. So delete unused if then old style parser. Okay, so now I don't think anybody's referencing statement except statements. Statement equals try statement. That's statements, and here's the function. Okay, so if I delete this, okay, should be one place complaining, or two places, one method. Statements, okay, and I'll delete. Nobody should be referencing this. Let's make sure that's true. Okay, good. We can delete that. Now it should build and run, and we're using the new style parser for if as well as everything else, and only that. So for a while we were using the old style parser the new style parser could get to the if then, but then the if then was calling the old style parser for statements. Now we've closed the loop, so the if then is calling the new style parser. Okay. But we couldn't make that change. Remember, we had a constraint that says old parsers can't call new parsers, so we couldn't do that until we were ready to flip the whole thing. All right, now, where's that leave us? Okay, progress-wise, I lost my keynote. I must have maximized a window there or something, huh? Not the first time. Okay. Yeah. All right. So we did if. That's a big step. And again, it's that big red double-headed line, double arrowed, saying if depends on statements and statements depend on ifs. It actually should be pointing at statements, but that's okay. All right. I don't see any reason. Well, okay, we got wrap old expression. That's gonna be our next hurdle. Once we get the statements done. Okay, like, is there any reason to do one before the other? I don't think so. We have to just do them all. Print on. I don't know. This one's a little tricky, ugly. Okay, let's just start at the top and go. I feel like I'm reformatting this thing a lot. All right, let's do define. Okay, so define required. This one's kind of complicated. All right. Let define def parser equal match def and match function. Well, it's almost this text, isn't it? Match function with def requiring the name of a function. Okay. And then I think I'm going to put this here. And then we need require function. Okay. Then we need a variable with this message. Okay. Name equals token.string. Okay, well, that's the name variable there. Okay, this has a constraint. Let's leave the constraints off for a moment. Then we need a left parent. Okay, so this thing, okay, we got to keep the variable match left parent. Was there a message? Match left parent. Okay. This is an old style call. Well, let's wrap old something. Self and require variable. Left parent variable. Oh, this is the parameter name. Okay. And a right parent. And equals. This one's kind of like not fun. Okay, and an equals and an expression of float type. We'll just do the we won't put the float type requirement in just yet. It's another wrap old. Self expression. Okay. Require float type, and then the whole thing returns a thing. It's going to be a messy thing, but something like that. Okay, what else we got here? All right, they should be complaining nobody uses def parser. Okay, still got some issues. Upper and requires token and input be equivalent. Okay, so I probably need parentheses or something here. We match the def. We're going to keep the function. Oh, we don't really need this either. Okay, so we match def. Keep the right hand side. Well, all right, let's work on our formatting. So match that. This one, we don't need the function fn because we know it's the literal fn. But this one, we got a variable. Okay. And then the left parent. Oh, wait, what's this require variable? Variable equals token type. No, this should just be match variable. With that. Whoops. I'm messing up something. Okay. So function fn variable left parent. Okay, that's correct. Oh, and this is another variable. Left run try require variable. Let's go in there. And it returns it. Okay, that's a little weird. Okay. Function variable left parent keeps that. And wrap old required variable match the right parent. And match the equals. That all makes sense to me. Okay. Function we ignore. Match the variable we keep. Match the left parent we ignore. And the variable. So that should give us a pair of variable string or token string, and then match the right parent ignores. And what's this? Requires. Well, let's pull this out then. Requires equal. Okay, so we'll take this entity. We'll keep the left-hand side. I think this one's probably not helping me any at this point. Okay. We got, oh, come on. Less than requires satisfy token and input be the same. Nothing dot input. Okay. It's still not happy. Make sure that build is. Okay, so it's somehow. The match is going to keep this one. Whatever this giant thing is, this should be ignored. It should be required, but then ignored. Oh, wait, what's the word require there? That should be match. Okay, that's better. We're getting there. Okay, so this produces a pair of variable and string. This ignores that. Equals. Then we have to get the expression. So now this is a pair and an expression. Okay, so this is variable name an expression in, and we don't need the word return because it's a one-liner. statement.define function plus name. I guess I can indent these. Okay. Closure tuple parameter does not support destructuring. Fix. Closure captures parameter before it is declared. Variables never used. Function. Well, this is really token name. Okay, so the token is the variable which should be function. This should be token dot string. The parameter is the name. The expression is an expression, and that. Okay, closure captures parameter. Statement is unused. Oh, now it's got to be a return. Okay. And since I told it statement, I probably don't need that. All right. This is one of the worst ones. Okay, I'm going to cut this. Going to put it up here with statement. Data, this is define. Okay. Def parser. And that replaces this. And if I've done it right, it should be good except for an error message or two. We didn't put a required type thing in there somewhere. Okay. Define function name cannot be followed by extra letters. Okay, yeah, we didn't put an error for that. And must have numeric result. Yeah, we didn't put the error in for that. Okay, we can do that. Okay. I think this maybe if we do that here, because the name here is the thing that has to be one letter. So I think we want to do a more complicated, make a support function for this. Let's call it, well, it's like make def statement. But it's also going to check things. So, I don't know, but it's going to be this sort of form again. So we'll make file private function make def statement. Okay. The values coming in, it's that triple thing here. And its type is nested with expression, token, and string, and that may get worked over at some point. Remaining array slice of token, parse result turns tokens into statement. Okay. And so instead of this, we're going to call, make def statement. And we'll return this. Got too much stuff going on here. Okay, this doesn't need to be there. Okay, and I think we might be able to do it in one line. Okay, let token name expression equals our parameter thing coming in. Has no statement. Oh, right. Success case. Let's let statement. Equal that. Really? And remaining. Okay, so the way we are now, we're not checking anything, and we just always return success. And then we're feeding that into this, which is sort of that cross between a pipe and a parser. It runs, it takes the stuff it's given and runs through this and comes up with a success. So I should have the same failures. This is kind of a complicated extract method. Okay, and yes, same too. All right, now I can apply the rules. So let's go down to define again. Okay, and get the messages. So this rule, and then where's expression require float type? Okay, so guard name.count equals 1. Otherwise, we're returning a failure. Now the position's a little weird. Let's do index of token and this message. Okay. Dot failure. Okay. So if the count is not 1, then we return a failure with that index. Ooh, 2 failures. Let's see this. No error found. This one's numeric, so that's irrelevant. It's this one. Function name cannot be followed by extra letters. Okay, I think something's a little funny. Def require variable. Well, that's not that one. This is token. Okay, let's see. I'm looking at the wrong thing. Token.string .count equals 1. Okay, so the token, it's fnx, or x9 in this case, the error case. fnx9 is the string. So its count is 2 instead of 1, so that should be okay now. Yeah, and we got this numeric result. Okay. Let's go back down. Whoops. Oh, that's what I did. Okay. Find, define. I just want to get the message right on the expression. Oh, require float type. Okay, let's... Okay. And back. Okay, so now we're going to check the expression. Guard expression dot type is number, else get some sort of failure. Accept token numeric is required. Okay, and this kind of points to a flaw in our error handling, I guess you'd say. We don't have the expression does not have a location per se. It's no longer a token. Our tokens know where they are, but the only token we have to talk about is this one. I don't think our test is particular about exactly which one gets highlighted, but it's going to be a touch weird. It's not totally awful, but it's not. I would rather be pointing at the expression itself, not the token. But the token is the only thing we have that knows a location that we can use. It would be a reasonable change to make expressions know a location as well, and maybe we should do that at some point, but not today. It's a new project. Okay, so we change define to new style parser. Okay, and it's a little awkward. Let me... Okay, let's clean up the define first, and then we'll deal with it. Okay, so this should have no callers. All right, we'll take this out. I mean, you can see we saved a little space maybe, but it's still somewhat awkward. It's kind of another awkward statement. All right, this should pass. Okay. What I was wondering is we had that require float type we defined. I think maybe we could use it down here. Let's see, where is it? Require float. Who called that? It was our ifThen. Okay. Def require variable expression. I think we could say this is require float type. Just like we did in here, expression require float type. Yeah, I think that is a good place. Let's make sure it doesn't break, and then we'll make sure we can delete the other. Unknown statement. We're back to this backtracking thing, aren't we? Okay, I'm going to undo that. Okay, we're back to where we were. All right, let's see. So we've done define. Now dim for GOSUB GOTO. Okay. Oh, let's mark it in progress. Dim. Okay. Dim statement wrap stuff. Dim. Okay, so dim parser equals, we got a match dim. We don't care about it, but we care about the rest. Okay, this may be interesting. All right, so dimension statement looks like dim a sub 3 b comma b sub 4. Okay, setting array sizes. Okay, so dim 1. Okay, well let's wrap old dim 1. And what does it return? It returns dim info. Okay, so we got wrap old dim 1, and then these things are separated by commas. Okay, and then in the end we just produce a dim result. Oops, bar greater. We're given an array of dim infos. Okay, so this goes to statement.dim $0. Okay. Def, then dim. Should work. Now dim is no longer used. I'm going to leave dim 1 for now. Let's get our statements done, and then we'll come back and tackle anything left. And it's got moderate complexity too, doesn't it? All right. Dim is done. Whoops. Take one of these. Okay, 4. That's going to be a little complicated. It's just oddly complicated structures sometimes. I mean, it was 1964. It was defined, or 65. So, the things we know now about languages didn't have time to percolate there. Okay, so this is a 4 parser. 4 parser equal. We got to match the 4 and ignore it and require variable. So we get wrap old, require variable. Okay. And less and match equals. And we get an expression. I'm going to skip that for now. 2. The final expression. The step. Okay. Oh, this is a little. Okay. So we got the expression, and we need either. Well, we need and. Let's see. We may have a. This is optional. We may have. Sorry, optional. We might have a step and an expression. Now we got to make sure we default that to 1, otherwise. Maybe we're okay. We can let the semantic routine deal with it. All right. And then we want to do a 4. Okay. So that should produce an optional expression for us. Okay. And then pipe this thing to that. Statement.4. Okay. It's going to be messier, though. Okay. Let's see if we get our pieces right. We got 4. variable equals expression, keeping those two, to expression. Okay, so this is variable expression 1, and then that is expression 2, which is 2, which is fine. And well, maybe I'll call it expr from expr 2. That, and then we wrap it with the expression, which is required, and then we wrap it with a step optional. Okay, this should be complaining the types are totally, it's not going to like that. Okay. So let's take this here. Okay. Can I say bar from 2, comma, step optional in this, and then I've got to break apart bar from 2. Let variable initial final equal var from 2. Am I allowed to do that? Okay. Step is optional. Sure. Statement. Okay, and so if step optional, else, well, let's let step equal step optional. Otherwise, I think it was dot number 1. Yeah, expression dot number 1. Okay, so if you don't have a step, we define a default size for you. Okay, so, woof. Okay. What's encouraging is this stuff, it's complicated because it's picking out 4 things, but I apparently picked up the right 4. So let's move this thing back up. And again, we have not enforced the float types on those 3 expressions. I don't know. We may find a better way to do it, but let's def if this is a 4 a FGHI, right? Okay, 4 parser. 4 parser. All right, so I expect it to work except for the required float stuff. Okay. Requires numeric expressions. Checking each one. Good. Okay. And again, I feel like there's something on the... I would like to do this. But I don't think it's going to work. Invalid. Conversion? That sounds like I left something out, doesn't it? Invalid conversion from function O type expression throws produces nothing. I don't know what that means. Let's undo. Make sure that's back. Sorry, for parser. Wrap old. I'm puzzled. A require flow type should produce expression. Okay, so let me try this again. Wrap old should produce expression. That should be no problem. Oh, I had the wrong operator. Pipe and greater require float type. It should parse, but I got a feeling it's going to have that backtracking issue again. Oh. Unknown statement. Trying to think the right way to get through this quickly. I think I'm going to push. Okay, what's going on there? Let's see. Can we work this out? It hits this. It hits a failure here. I don't know. It might. Because these are not backtracking. And that's what's confusing me. So this, once it matches the forward, it's kind of committed to this thing as long as it can move forward. But when it blows up here, did I leave in a bar one? I think I have to have one bar for that if then. Yeah. Sorry, let's see what we got about backtracking in here. Okay, addition precedence. Succeeds if either parser succeeds. On failure, it returns the failure that got the furthest. Okay, and then the message, use the result of P1 if it succeeds or makes any progress. Or a failure if it makes no progress. Yeah, so why are you making no progress? Alternative, returns, the first parser succeeds, it returns that result. That's what it should say. If it fails with no progress, it returns the result to the second parser. So I don't know why we're saying this is no progress, because it looks like progress to me. I don't want to get totally stuck, but like, I wonder if... No, I mean, it makes progress because it got past the 4. So it's not dying until it hits this, because that it made it past here before. So it is this that's killing it. Are we... Maybe it's the token. Does it require float type? Parse expression to type. Oh. Wait, where's that coming from? That's totally weird. Token is the current token. Yeah, the token is 0 because... Okay, I think I know what's going on. This is something to do with the backtracking. So in our wrap old, when you parse something with the old recursive descent, you first put the current token up to where you want to start parsing, and then you parse it, and then at the end you put the token back to where it was. And I think because we're totally getting outside of our expression, we don't know that it got that far. So token has been reset before we get a chance. And really, it would be nice. It's really remaining. Okay, maybe this can help. It's remaining dot start index. Okay. It's just kind of dumb luck we had that token field sitting around. It's not the current token by any stretch. Usually it is, but because we're in the backtracking part of the world, the commentator stuff doesn't recognize it. Now I think we're saying whatever came after the first character after the expression is where we notice that things are wrong. And so I think actually it's -1. We know there had to be something in front of an expression. You can't start a statement with an expression. Or I should say, yeah, you can't have an expression of 0 length, so you're never going to get to -1 or anything. Okay, let's see if that's any better. So I think because it went back to 0, yep. Okay, because it went back to 0, it basically reset the counter and went on. Okay, what's the other failure? I'm only seeing one failure. I think these are both failures yet. All right. Okay, that might have fixed something else too. Let's see. Where's our 4? Getting lost again. Okay. So I think wrap all self-expression on all 3 statements should be that. Okay, that should fix that. Okay. Okay, that's better. Now, we had one that did it, right? So where's our make def? Was that the one that didn't enforce this? Make def require variable. Sorry, it's the expression that has to be, right? Expression has to be numeric. Okay, so this should also be ampersand require float type. Okay, that should be harmless. All right, now I can take it out of here. Okay. Okay. All right. Okay, let's hope this is an easy one. GOSUB. Okay. Looks short. Okay, GOSUB parser. GOSUB parser is match GOSUB and match a line number, I guess an integer. Match integer. And if you don't have that, you get this message. And once you have that, you can say token in and return. Well, I guess I don't need the return if it's the only statement. Statement.GOSUB line number of token.float. Looks good. I probably can go back there. Yep. For GOSUB parser. This should work. Delete the old GOSUB. Should still work. Good. And we'll go on. Okay, my to-do, I haven't looked at that very much today, have I? EVO-22-15, last day of August. Oof. Okay. What have we done? We did, well, one word statements, read, data def dim for GOSUB. And if. Okay, does that still convert? Well, this is really remaining statements to parser. Okay. Let's see. This was green. Okay, go to. Match go to. Well, this is very similar, isn't it? So similar, I think I will just copy what we have. Oops, got a little too far. Okay. GOSUB parser. GOTO, interesting target of GOTO and GOTO. All should pass. Well, convert GOTO to parser. I wonder if GOTO. Nope, no references. All right. What's next? GOTO's done. Let's do input. To input. Okay. This one's got a little bit of stuff. All right, so let input parser equals. Well, you got to match the input token. And then I guess we need to match the string as optional. match.string followed by a semicolon. Match the string and match a semicolon. Why are you not happy? Okay. That's a match. That's a match. Okay. So all that stuff and comma list of variables. Wrap old self comma list of variables. Okay. And then we need to default the prompt. Okay, but we're doing this. Okay, this is return statement dot input prompt. Okay, and so our prompt is an optional prompt. And a variables. Okay, in let's let prompt equal prompt optional or prompt optional dot string or empty string. Prompt optional. I don't know how I can. Okay. This was input parser. We'll quickly see if this works. Whoops. Oh, we got rid of GOTO. Oh, which means I messed up and not run tests after I cleaned up. That's terrible. Okay, well, that's the end of the day. It gives us a place to start tomorrow. Tomorrow, Thursday, we will start at 1 p.m. Eastern Time or 6 p.m. UTC. I am confident we will get through probably the rest of the statements. We did about half today, so it should be picking up, right? We'll get through these statements and finish the input one, fix that. Basically, our test relied on the parser having a GOTO method. Doesn't exist anymore. We're cleaning out. I'll probably put it back for now, and we can use it for tests. But thanks for joining, and I hope to catch you tomorrow or in the future. Bye-bye.